Okay, students, so now we're going to do another calculator aid for hypothesis testing and confidence intervals for means. This is going to be with the assumption that we're testing and trying to estimate mu when sigma is unknown. This will require a t-test and a corresponding t-interval. In this example, talking about rainfall, they give us information in statistics. They claim the rainfall is 11.52 inches. And they want to see if the rainfall has been reduced. So what you're going to do, of course, is turn on your calculator. And this is for the 83, 84 pluses, by the way. You're going to go to STAT. You're going to go over to Test. Since sigma is unknown and we have sample standard deviation, we're going to go to a t-test. Now, they gave us statistics, so I make sure that stats is highlighted. If they had given you raw data, you would select data. And the data, of course, is data you stored into list 1. Mu naught is 11.52. It helps if you type correctly. X bar was given to us as 7.42. And SX, remember, that is the sample standard deviation. That's your calculator's notation for that. And it was given to us as 1.3. N in this problem is a very small sample size of just 10. Another reason to do a t-test. And we're testing to see if there's a reduction, so we need a less than symbol selected. And then we're ready to hit calculate. We're trying to get a p-value. We get a very small p-value, 1.8293, but it's e to the negative 6, which means it would be 0.0000 1 point, 1, 2, 3, 4, 5, 6. Sorry. Okay, I do have the correct number of zeros. 5 leading zeros in front of that number. So it's very, very small. It's a very, very small p-value. So it's definitely going to be less than, so we're definitely going to reject. And then, of course, you write your appropriate conclusion. Okay? So that's how you find the p-value when sigma is unknown and proceed with your hypothesis test. Let's assume now that we wanted to find a 95% confidence interval, maybe a corresponding confidence interval. What we would do is go to the stat menu, go over to test, and instead of t-test, let's find t-interval. So let's select t-interval because, again, sigma is unknown. We select it. We have statistics in this case. Again, if you have sample statistics, if you have data, use data. Check your mean is correct. Check your standard deviation, SX, is correct. Your N is correct. And we want a C level of 0.95. So change that to the appropriate confidence level that works for you and your problem. Hit calculate. It's going to think about it for just a few minutes. Sometimes it takes a while, especially on these older models. And it's going to bring up a t-interval of 6.4900. The float is set to 4, so that's why we're getting these trailing zeros, to 8.3500. Okay, and then of course you would write your interpretation. Based on the evidence, we're 95% confident that the true population mean lies in the interval 6.49 to 8.35. And that's how you do a hypothesis test with a confidence interval using the TI-83, 84 pluses. Again, when sigma is unknown, that's a very important distinction. Sigma is unknown. Most common case.